Now, having seen both external hashing and external sorting, how do they compare in terms of performance? We can answer this question by examining the way that they do I/O and use memory buffers. Here's our schematic for external hashing. We read in the input, we partition it, we write the output. Then we read in each partition, we conquer it by building a second hash table, and we write the output back to the disk. As we know, that's roughly 4 times n IOs for a file of approximately b squared in size. Now, when we think back to sorting, the pattern is actually familiar. For sorting, what happens is we read in b blocks, we conquer it by sorting it, and we write out a run. Then we do that again, and that's pass 0 of sorting. After that, we run the so-called divide phase, which really is the merge phase, where we put these runs together through merge to generate a sorted output. Again, we read in the input and we write the output in pass 0. We read the results and we merge them when we write them back in the output. That's for a file of approximately b squared in size. So hashing and sorting in terms of their I/O behavior are very, very similar. And in fact, you can convince yourself that they do the same number of random IOs and the same number of sequential IOs, just in different phases. That's why sometimes people say that hashing and sorting are dual algorithms, that is sort of the mirror images of each other. And you can see why that's true from their I/O patterns.